Hello, everyone, and welcome to our today's Quanser webinar, introducing Quanser Interactive Labs. My name is Zuzana Fabushova, and together with my colleagues Paul Karam, Director of Engineering at Quanser, and Peter Martin, Quanser's R&D Manager of Academic Applications, we will be your hosts and webinar moderators today. And because all of us are closed in our home office, we thought it would be a nice thing to attach some faces to today's webinar. So hi from Canada.
Hello.
Unfortunately, Paul doesn't have a camera on his home desktop in his home office. So you see only two of us. So we will shut down the cameras for the rest of the presentation. And with this, I will ask Paul to introduce our solution.
Thank you, Susanna, and hello, everybody, and thank you once again for joining us today from all over the world. And it's really exciting for us to be putting on this webinar. As most of you know, a lot of you are quite familiar with Quanser, and for the past 30 years, we've been working with professors just like yourselves, institutions just like yourselves in academia, to really bring hands-on education to the forefront of engineering courses, both in undergrad and in graduate work and research. And we fundamentally have always believed and still believe that a hands-on approach with hardware is the best way to complement any undergraduate course, and for sure any graduate research. But we are in unprecedented times. A lot of you had to scramble really quickly, as many of us are now practicing social distancing and not being able to physically come together, which makes things like lectures quite challenging, and even more so hands-on labs with real hardware almost impossible, if not really challenging. And so, as all of you are quite aware, Quanser has been in the business for 30 years, doing working with many of you to bring hands-on experiences in the areas of control systems, mechatronics, and robotics. What some of you might not know quite as much is we also have quite a bit of software pedigree and software assets that we can bring to the table as well. And so, as we've always done in the past, we look at where the trends are and where your needs as our customers, as our colleagues are right now, and try to bring forth a solution that meets your needs as seamlessly as possible. And that's really where Quanser Interactive Labs was born. I mean, the actual software and technology here has been in development for quite a few years, if not longer. At Quanser, it was just with the changing times, we were able to bring it all together, because these are unprecedented times, and we've heard from many of you over the last few weeks and last month of your burning need and desire to deliver your content, deliver your courses online, yet still provide some lab experiments to all of your students that are now remote. And we wanted to put something together out there, and this is what we'll be launching today. And I'll be passing it over to my colleague Peter Martin to give you an overview of what we put together. And really, this is not the end-all solution. This is really the beginning of what we will be developing over the next little while. And what you'll see as throughout this webinar, and you'll see, please still stay connected with us over the next few weeks and months, we will be releasing many more examples like this, and new approaches to how you can still provide those hands-on, interactive, enlivened applications from a distance. And really, that's why we're here today. Again, thank you for joining us. We hope you enjoy what you see. It is in its infancy, and like I said, this is just the beginning. So please give us your feedback, give us your suggestions, and we're looking forward to working with you to make sure that whatever we deliver, wherever it gets to at the end, meets your needs today and is scalable for anything you might need within this type of approach tomorrow. So with that, I'll pass this along to Peter Martin, manager of all of our applications development and our applications team, and he will let us know about Quanser Interactive Labs. Thank you very much. I hope you enjoyed the webinar, and we look forward to all your questions at the end. Over to you, Peter.
Thanks, Paul. Hello, everyone, wherever you are in the world. Thanks very much for joining us today. We really appreciate your time, especially with everyone, as Paul said, in unprecedented circumstances. We've been doing our best to try to create something that can address the needs that are emerging in our community, and that's what we'll be talking about today. What we're going to touch on, we view as basically our world-renowned Quanser hardware, which I'll start by talking a little bit about, but now available on your desktop and in your pocket. So as Paul said, in all of the difficult circumstances that we're facing, and with that, I hope everyone is safe and healthy and happy. That it's difficult for us to be able to give students the experiences that we as a company have been working on for over 30 years in terms of being able to bring students to experiences that give them the insights and the skills that they need for their future careers, whether they be in academia or in industry. And so with what's been happening in the last few weeks, we sat down only about 2 weeks ago to start to figure out what we could do to help our customers, help our partners, and also help students to get those experiences without being able to be physically present, as Paul was saying. And so what we put together is, we hope, a good starting point towards being able to give those experiences to students now in the next few weeks and months, and also for years to come. So with that, I'll start the presentation the same way that we start all of our presentations, which is to talk about who we are as a company. This is our DNA, essentially, that we as Quanser, we come from the amalgamation of question and answer. So we come from not just on the R&D side where I live, in terms of the asking questions about how we can bring cutting edge technology and emerging trends in industry and in academia to students and to researchers in effective ways, to be able to have them have the tools that they need to be able to do what they do better, but also that academic focus. Like, we've been an academically focused company for over 30 years now, and what we try to do with all of our technology is bring that academic flavor and that continuous iteration and continuous improvement, whether it be technology, solutions, approaches to pedagogy, to everything that we do as a company. And as I said, that's been something we've been doing for over 30 years. You can see there one of our first hardware plants we started with in the 1980s, as our founder, Jacob, really saw a challenge then, to bring students again in front of hardware and give them those skills and experiences that they needed to be able to be successful in their careers. And so he built these first products to really bring hands-on learning to students in the control space. And over the past few decades, it's only grown from there to encompass robotics and mechatronics and more advanced approaches to teaching and pedagogy, as well as being able to stretch out into other fields as an R&D company in terms of haptics and advanced robotics and things like that. And in the last 10 years, getting into the unmanned vehicle space, where you can see there one of our most advanced systems, the Quanser drone, as well as some of our new products we released this year along the lines of self-driving cars and other more advanced robotics platforms for research. And so that research approach has also been something that we've been founded in terms of being able to bring these really cutting edge advanced technologies to researchers, to really give them effective validation platforms, to be able to take the research that they do, their algorithms, their new innovative approaches, and be able to really quickly and easily implement them on hardware platforms without having to worry about having to create unnecessary software platforms or tool sets or modules that don't really influence what they want to focus on, but give them the results that they expect and the results that they're looking for, and also a way to bring those algorithms easily to, as I said, emerging trends, whether it be AI or machine learning or Industry 4.0, things like that. We're always trying to push the boundaries of what can be done quickly and effectively in the academic space in terms of bringing in advanced technologies and adapting them to that academic focus to make these academically appropriate solutions. But it isn't just in the research space that we push the boundaries. In the academic teaching space as well, we've worked with a lot of partners over the years to bring really advanced pedagogical methods to what they do in their teaching courses, whether it be bringing advanced hardware to early years courses, or new approaches to how content can be presented to different different undergraduates in different ways. I'll talk a little bit about that later on in the presentation, but even sort of how you can change the whole structure of a course or a program to really offer meaningful experiences for students so that they can really understand and connect with the advanced concepts that are typical in day-to-day engineering life, but from the very early beginning, so that they really understand and connect with what engineering is and bring those experiences throughout not just their undergraduate career, but as I said, later on when they get into whatever the path they choose in their future careers, we're being able to really understand what it is to do engineering and how theory and practical applications come together. And again, just to pull that all together, this is something we've been doing all over the world for a long time now, 30 years. At this point, I think we're well over 3,500 academic institutions all over the world, with a similar number in the thousands of research papers that have been published using our technologies. They're fully available on our website if you're interested in how we've had an impact on your particular field of interest. We have them archived and you can take a look through and see how people are using our products to push the boundaries of their particular research interest. And from that has also come over 80 core products and solutions in the hardware space as well as in the software space to really bring those hardware experiences to researchers and to academics. And so if I have to sort of pull all that legacy together and pull what we do as a company together into a single approach, it would be that we try as much as possible to make robust and expandable hardware platforms. As you'll see in a little bit, that also extends into our software platforms, but also to make sure that everything is open and transparent in terms of the architecture of the platforms. We don't hide anything. We don't like to have black box algorithms or hardware so that you don't know what's happening. We feel it's really important, especially in the academic space, to have everything exposed so that students really understand the integration aspects of how hardware and software come together and how the different elements of systems influence each other. We, as much as possible, try to bridge some of the gaps or smooth over some of the potential issues they might encounter in terms of interfacing and being able to effectively implement some of their systems. But we never hide anything, and that's something that we've always been very passionate about. These experiences are fully documented. That's what I've been doing for over 10 years now, is trying to bring what we do on the hardware space and the software space to a teaching context in terms of creating curriculum resources and even immersive experiences, whether it be in different types of reality spaces, which we'll also talk about in a little bit, but also in terms of being able to push the boundaries of how courses are presented to students, whether it be student-based learning, studio-based learning, or problem-based learning, or things like that. We really try to push the boundaries of how our content and our hardware can be applied to the academic space and especially the teaching space. And with that, we always try to make sure that we're aligned to engineering courses and research. Everything we do is sort of continuously following moving targets in terms of emerging technologies, changing approaches to how engineering courses are delivered and the sorts of courses that are taught. As technology moves, so does the skills that are required by students to be able to address those skills. And so we have to make sure that we're up to date on what is being taught, the emerging courses and trends, and making sure that we can deliver products that really address those in an effective way and highlight those modern techniques to make sure that we also bring from everything we do from the hardware and software stack all the way up to the teaching materials, experiences that really offer not just what instructors and students expect, but what they might be able to see in the future in terms of how these systems come together and how we can deliver these really meaningful, technologically advanced solutions to students. And so the task we had, just to circle back around to the beginning again, when the current crisis started to come to light and we realized that there was going to be a disruption, let's say, in terms of how we would typically deliver our products and provide these solutions to instructors. Our first challenge was looking at our legacy in terms of what we do as a company and thinking about how we can take that and take all the lessons we've learned over the last 30 years and apply that to changing what we do and pivoting to a certain extent what we do so that we could address these challenges. And so the first thing that we did was start to look at, as PK sort of talked about, the assets that we had as a company, the technologies that we'd pulled together over the years to address these cutting edge academic trends and to bring these cutting edge teaching techniques to our customers and our partners, we tried to think about how can we start to look at those and see them from a different light from this distance learning context. And so the first thing we did was look at our virtual reality technology platform, something that we call Quanser Sim, where we have these ability, this technology that allows us to represent our hardware in a very effective way in virtual and mixed reality spaces. As you can see here, typically what we've done with this technology up until now has been this kind of representation of how solutions can be brought together to be able to show our partners how they can leverage our technology in really interesting ways to be able to provide solutions to their students and to their researchers. But this was basically the most that we'd really pushed in terms of being able to leverage this technology platform. So we had the ability to create our systems, to work with them in virtual reality. We had the ability to have, to a certain extent, hardware capabilities as well, but also we had the ability to represent them dynamically, which was very important. But at the same time, again, we'd never really leveraged this technology in terms of the teaching context or being able to use this effectively in the laboratory space or the virtual laboratory space. The other piece of technology that we'd worked on that was something that I've been a proponent of for the last several years, 6 or 7 years now actually, was our QDEX platform, which is our platform for being able to bring traditional engineering content to mobile devices in a really effective, interactive, and engaging way, to really take the traditional engineering content and engineering techniques of teaching materials that are advanced and technologically involved, as well as being theoretically pretty deep, and present those to students in a context that really allows them to understand and really engage with those concepts and play with them and interact with them in ways that they had never thought about before, to bring that understanding of how these techniques apply to engineering and also apply to real world contexts in terms of industrial applications and things like that. So this technology we also had ready to go, and we'd used it for a number of partner programs and courses. We'd used it to build out our mobile textbook, which I'll talk about in a couple of minutes. But again, we hadn't, other than the mobile textbook, we hadn't really brought this interactive laboratory experience to our students or to our partners in the same way by leveraging this technology. So that was the other platform in terms of a technological asset that we had that we thought we might be able to leverage for this. And then finally, how could we bring those together to do what we always do as a company, which is bridge that gap between theory and practice. That's what we always try to do with everything that we create, is bring those theoretical foundations that are part of everything you do in engineering. And obviously the application context in terms of being able to apply those theories to real world hardware, real world scenarios and applications, and see how the two of them come together, how theoretical elements of modeling and of dynamics and of how, especially for us, controls and algorithms affect real hardware, and vice versa, how that hardware changes the way that those theoretical elements are applied and how they actually justify their functionality. And so those were the elements. Those were, for instance, the ingredients, let's say, and what we had available to be able to bring a solution as quickly as we could to our partners to be able to address the needs that they had. And finally, we had this experience controls platform that I mentioned, which was for us a legacy now of being able to bring really advanced and really exciting technological and teaching materials to students. Experience Controls is our control systems textbook that we released last fall, that allowed us to be able to bring what was traditionally one of the more not necessarily behind elements of a controls course, but the elements of the controls course that we thought needed a little bit of a modernization, a little bit of a refresh in terms of how the content was presented to students. And so we took the traditional controls course textbook content and we ported that to our mobile platform, really enlivened it, enriched it, made it much more interactive for students with simulations, with applications, with the ability to see how, again, those theoretical concepts come alive in these applications. And that had been hugely successful for us. We've seen over 4,000 student downloads and over 200 or 300 instructor resource downloads from this platform. And so we knew there was a hunger to have this ability to interact with theoretical concepts and really understand them in a meaningful way. And so that was our foundation. That was our starting point 2 weeks ago, to be able to try to bring something to the growing need that we were hearing from every available outlet that we have that's exposed to our customer base, whether it be phones ringing off the hook, but again, there's no one at the office to answer them, or emails. We know that there's a growing surge of need for a solution that can bring those experiences to students in an effective way. And we had all these great ingredients that we knew we could use to bring and deliver something as a really effective solution. And that's basically the motivation behind what we've created. Is we've always worked with our customers as colleagues to be able to stand by them and drive everyone towards success, whether it be their students or their researchers or our other academic partners, to try to be able to deliver something that can make sure that everyone is able to succeed no matter the circumstance, which obviously in these circumstances is a little bit of a different challenge, but we had these abilities and we had these assets that we knew we could leverage. And so the rest was time. And after a lot of time, we, in terms of late nights, we've created something we think is a really effective starting point, not just to address the current need, but as I said, to serve as a platform for being able to really deliver interactive, engaging, and robust virtual experiences to students outside of the traditional brick and mortar lab, if you will, in a distance learning context. And what we've called that is interactive labs, Quanser interactive labs. And essentially they're interactive experiences for lectures and for labs. Obviously labs are first and foremost what we do because that's our legacy, but more and more we're seeing hardware interaction and this sort of engaging interactivity being brought to the lecture space, because that's again an element of the typical course where that interactivity and that engagement is sometimes lacking. And so being able to show students in a lecture context exactly what you're talking about and exactly what the theoretical applications are is a really effective way to show them the real context and the real application for how these sorts of theories come together. And so with this platform, what we've delivered are what we call credible lab activities. So that's sort of academically appropriate activity that I talked about a little bit earlier, but they're accessible off campus. Students can use them on the metro, in their lab, in their dorm room, in their bedroom, wherever they have a mobile device or a laptop available, they can have these experiences. And we really believe that they are credible in terms of being able to deliver the same experiences that they would have in a traditional undergraduate lab context. They can be integrated, as I said, into online lectures. We've also talked a little bit about how they could potentially be integrated into more advanced online activities, like maybe online studio contexts or other project-based learning applications where students are not just interacting with online content or online lectures, but actually being pushed to have traditional cutting-edge pedagogical experiences, but at a distance. And potentially what we hope this might do is actually bring even more interaction and engagement to even traditional courses compared to how they would typically be delivered. This could actually end up being a mechanism to allow your students to interact with content, interact with systems, and have a much more engaging and effective learning experience than they might even have if they were in a traditional context. But again, because of the current need and the current climate that we see with our partners and in the academic community, we wanted this to be something that was immediately available, something that you could access today on Windows, iOS, Android, and in the next couple of days, macOS, and something that would not require any kind of infrastructure, anybody necessarily on campus to do configuration to set up licenses. This is something that's available to all of your students, no matter how many students you have, and they can download it and use it today with very little requirement for there to be any kind of integration or any kind of activity to make it possible for the system to be used. It's ready and you can use it today without any other oversight or requirement. Because of that, again, it's much more scalable than the approach you might typically expect from a company like ours in terms of remote access. I gave a webinar 3 weeks ago on remote access tools, but again, since then, times have changed. And so being able to deliver something immediately without any kind of oversight, any kind of configuration activity, but also something that's infinitely scalable in terms of being able to offer this solution to tens, hundreds of students, is something that we thought was much more valuable than having something that we'd always stood by in terms of having that real world hardware experience. We intimately understand that there's nothing like a hardware experience, and nothing like sitting in front of a piece of machinery and working with it and understanding what it's doing and how the software and the theories and the applications and the hardware all come together. But at the same time, that does present challenges. And so what we've done with this platform is bring as close as we can for the context of how this is going to be used, that experience without needing all of that infrastructure and all of that resource intensive configuration. And this is a little bit of how it looks if you access the app. So this is available now. We released it last night. As you can see here on the right, this is the desktop experience that's available at the moment on Windows and also in the next few days, hopefully on Mac OS. You can see here it's a really engaging virtual representation of our hardware platforms. And you can see as it moves, the response that you get on the plotting engine is as accurate as we could make it to how the real system actually behaves. We understand our systems very intimately, as you can imagine, through our very rigorous development process. We always, as a controls and mechatronics company, try to create models and create representations of our systems as effectively as we can. And so you can see here, because we have such an intimate understanding of how our systems are built and how they behave, we can really make these interactive representations and valid representations of how our systems behave and give students that hardware experience without actually necessarily being in front of a piece of hardware, especially tuned towards the outcomes we really want them to have in terms of the control outcomes or the curriculum outcomes. We really believe that we can effectively deliver some of those aha moments where they really see the difference between theory and reality and the effects that hardware has on some of these theoretical concepts through this platform, because what we've done is create curriculum that really emphasizes them and really showcases how these hardware techniques are really influence the theories that they understand from other resources. And you can see here on the left, we have almost exactly the same experience also on mobile, where they can interact with the curriculum. They can see, check your understanding questions to make sure that they're really following along and understanding the material that they're being presented with. We have assessment questions, so later on they can start to build a lab report in terms of being able to show how they've brought those concepts together and understood those outcomes I mentioned. But then they can interact with a representation of the hardware exactly the same way as on Windows, and hopefully more or less exactly the same way as on actual hardware. And this really gives them that experience on either platform, across the platforms, and also being able to give students who might not necessarily have PCs or high-end software systems at home the ability to, on their phone, interact with these systems and have these learning outcomes without necessarily needing to be on campus to even access the expensive IT resources that are typically there. And so this, combined with our traditional curriculum, which is, as I said, something that we also is fundamentally important to what we do, we've tried to build a complete solution, not just, as you can see with the laboratory experiments that we've built up in terms of being able to do basic controls for modeling position and speed control, but also an aerospace context for how those controls are applied to aerospace systems with our Quanser Aero. Things like PID tuning, gain scheduling, how PID gains are compared to more advanced topics like state space control. We've built up this collection of bespoke material specifically for this. This is not the traditional content or curriculum that we create for our other products. This is specifically designed for this context, so we emphasize how hardware influences these controls topics, and that was something we really wanted to consciously do to really make sure that the outcomes that students are getting on this platform are aligned to the outcomes that we would want them to have in a traditional context. And so we've really tried to emphasize those. But then also, as instructors ourselves, we wanted to also deliver a complete set of instructor material to our partners. So we have solutions for the assessment questions that we have available, implementation guides in terms of some of the ways that you can use this platform for your particular teaching context, and also lecture slides, because we always find that being able to tie lectures to laboratory activities really makes a more continuous and effective presentation of concepts to students. And so with that material, we really think this whole platform starts to come together in terms of being able to offer students the same experience that they would typically expect. On the assessment side, one thing that we're working on is currently we have the material presented on the Windows side just as the traditional open Word document and PDF that we always provide so that you can repurpose the laboratory experiences if you'd like to be able to give to your students. And on the mobile side, as you can see, obviously all the materials presented in our QDEX platform so that students can follow along on their phone as effectively as we can present the material. But on the window, but we're also moving towards being able to hopefully in the future offer laboratory report systems as well, to be able to take the material, for instance, off the mobile device, package it together and deliver it to instructors. And also on the Windows side, being able to take that material and deliver it effectively as well. So we're trying to figure out how we can build these systems as well to go beyond just sitting in front of the virtual hardware and doing a lab activity, but also the rest of the systems that are available in a typical laboratory experience, both for instructors and students, trying to bring those tools to you so you can use those. And so, as I said, with this ellipsis, there's more to come. This is just the starting point. In fact, the release that we had last night is only featuring the first 3 labs on the CubeServo 2. The second set of labs on the Quanser Aero, those should be released, I hope, today. So this is a very up and coming dynamic sort of development cycle that we're following right now. I've been calling it extremely rapid development, where we're building solutions as quickly as we possibly can and delivering them to you to address your needs as quickly as we can. But at the same time, we're trying to make sure that they are robust and they are following these mandates that we always have as a company. But with that, it's a work in progress. And so if you check back to our website for the desktop downloads and on the app stores over the next few weeks, you should see updates coming, not only in terms of being able to refine the software systems in terms of bug fixes and things like that, but also being able to refine the curriculum experience, add some features if we see fit, also hopefully add some additional experiences for students and things like that to try to build this out to be a really effective and really useful platform for you and for your students. And with that, we'd love to hear from you what you'd like us to work on next. As I said, this is a very just-in-time type of delivery process we're on right now, trying to make sure that we can address the needs that we're hearing about day to day as quickly as we can. And so, as I said, with our release yesterday, which was our first release of this platform, we were able to deliver the inertia disk labs for basic introduction to controls topics. Later today, we're hoping to deliver the aerospace context labs where we go through a progression of aerospace topics. But what's next? We'd love to hear from you what you would like to see. As you can see, we've made a start on being able to do the pendulum-based controls topics that we would typically do with our systems to introduce the concept of instability into how control systems are designed and created, as well as nonlinearity. And so that's something that we'd love to deliver. We've made a start on that, but again, we can prioritize as our customers and our partners let us know what they would like to see. And then also something that's near and dear to my heart, the Quanser ARM, which we've been developing for the last year or so, that hopefully will be released later this year. As a showcase and a little bit of a preview of that platform, we've also started to build out a set of robotics-based manipulator control labs. So you can also get a different context, a different feel for how controls comes to a different kind of complex system in terms of a serial manipulator. And so we have a series of labs there on joint control, task-based control, things like that, that we could also make available reasonably quickly to be able to address those sorts of needs. And from there, again, we have, as I said, over 80 products, and we'd love to hear from you what you would like us to bring to this platform to really address the needs that you have and the needs that you're seeing in your community, to be able to bring a platform that, as I said, has a basis in need and a basis of being able to deliver solutions that you can see being effective and being something that you can use immediately for your teaching activities. And so finally, I'll close this part of the presentation in terms of, again, why did we create this platform? First and foremost, as I said, we wanted to provide something as quickly as we could to manage the overwhelming set of requests that we're hearing from the market and from our partners in terms of being able to deliver something that meets your current need today, right now. And also something at that point that's also scalable, because your needs right now might be for something that has a large audience. And so we want to be able to deliver something that is immediately useful. And so from there, obviously we'll build up the platform to address more and more needs over time. But right now we just wanted to have something available that is something that you can use today. And then at the same time, again, use it as a starting point. Leverage our content delivery mechanisms, our simulation and virtualization IP, and bring all of our technology foundations together to be able to give these experiences now in the context of a very introductory or very sort of typical undergraduate laboratory experience, but grow from there. Perhaps offer experiences where researchers can start to use more accurate or more interactive or more, as I said, open and complete experiences for their topics. But then also being able to grow from the undergraduate context and the research context to other products, other fields. All these systems I've shown you in terms of the mobile platforms and the virtual platforms are underneath complete authoring environments. And so we have the ability to also work with partners to create custom solutions as well, both on the mobile side and the virtual side. And we'd love to hear from you if you have opportunities or see needs in that respect as well. And with that, without further ado, I'd love to just transition to being able to show you what the experience is like. I'll present the mobile side, and then I'll pivot to my colleague Paul Karam, who you heard from earlier, who will present the Windows experience. So if you just bear with me for 1 second, I'll get my phone connected here, and we can go ahead and give you that real experience. As I said, this is available right now on the iOS and Android App Store with the KubeServo experience, as well as from our website, which I'll link to later on in the presentation. You can download the Windows experience, and then we'll only be growing from there in terms of being able to offer more and more experiences to you. But this is the application platform, as you can see here, Interactive Labs, as it was released last night. And as you can see right now, it's the KubeServo 2 experience in terms of going through a basic introduction to control systems. So as you can see here now, being able to go through a modeling experience where, again, we start with motivation. All of our curriculum always starts with motivation. Motivation is a hugely important part of how we see engineering pedagogy. And so we really want to give students really upfront a feel for what the point of this particular piece of material is. Why are we learning about this concept? How will we use this in the future? And so we always start with that sort of context in terms of what is the motivation behind this particular theoretical concept. Talk about some of the main key concepts and system diagrams that are going to be in use in this particular laboratory experience. This material, as I said, has been custom designed for this and also designed in a context where we expect this to be used alongside material from another resource, whether it be a traditional textbook or online resources, or hopefully our experience controls platform. We expect this to really be sort of an introduction or a refresher on these concepts, just so they can check back with what the different sort of main elements of what they're doing are, but also for a deep dive into the theory, find another resource, hopefully ours or hopefully one of yours, to be able to get that really deep understanding of how these theoretical concepts are applied. But then very quickly, we'll jump right to the experience, right to the simulation, where you can run the simulation. You can see the response of your system. As you can see here, my red response is the actual system, and the blue one is my theoretical gains. I can tune that, run it again, hopefully get a little bit closer. As you can see, I overshot quite a bit, but basically now I'm interacting with this real system. I'm building my theoretical model to try to match this actual piece of hardware, in quotation marks, I suppose. And from that, I'm starting to understand how modeling comes together and how modeling can differ from real systems, which is the main outcome we want students to have with this activity. And then from there, I'll come back to the library. You can see here the library, which you missed when I wasn't showing it. And you can see the progression here in terms of going from modeling to position control and then to speed control. I'll jump one more time quickly into position control, again, starting with motivation, covering key concepts, elements of block diagrams and things like that to show how the system is actually architected, but then flipping immediately to the experience of being able to interact with this system and actually build a controller to try to effectively control this type of system, and also being able to show things like how modeled responses compare to actual responses and things like that as well. And then if you look here, I can actually go through a check your understanding progression and actually see, did I observe what I was supposed to observe with this? Am I starting to understand how these different elements of the platform and elements of the questions and the interactions affect those theories? And then finally, the assessment questions, as I said, where you can actually create long form lab report style assessments and submit those to your instructors. And hopefully in the future, that will be a little bit more integrated to really make that a simple and straightforward process as well. And with that, I'll flip to Paul Karam, and he can show you the Windows experience.
All right. I hope you all can see the screen that I'm showing right now. I'll just double check with the audience. Yes, you can. All right. So hopefully you're enjoying the webinar so far, and just want to reiterate, I've been checking all the questions coming in, and they're fantastic questions, and hopefully we get to a good chunk of them today. And obviously we want to continue this conversation. And really, I want to emphasize what you're seeing today is really just tip of the iceberg. So what we hope you're getting out of this is a package or some applications that you can start playing with immediately, right now, today, tomorrow, and provide them to your students that quickly as well. So that was the impetus of why we released what we've already released so quickly, and in its current application, it is being something that's fully scalable, that requires minimum IT. So anybody with a standard PC, be it Windows or Mac, or any smart device on iOS or Android, can have access and start learning and interacting with these labs tomorrow, right? So that was a big part of what we did. Having said that, what's part of the Quanser DNA, not so much just in the hardware, but in everything that we provide, is that openness, is that scalability. So you will see over the next little while us leveraging this technology in very different application areas. We've had a lot of questions already come up. For example, can this work with MATLAB and Simulink, like our typical solutions do, and things of that nature? And the short answer is it will, and we have a plan to release those capabilities. What we're providing right now is a completely encapsulated application that we've demonstrated on mobile, and I will demonstrate right now on Windows. In the future, very soon future, we will be releasing different paradigms as well to access this. And really, we want to, again, this is the start, and we want to continue the conversation with you as well. So just to continue with what Peter was demonstrating, this is the Windows side of the application. So a little bit different in terms of the look and feel, but the content, the expectation, everything's the same. So here is the position control lab, basically tuning a PD controller on our servo motor. And so you can see with on the Windows side, it is a full 3D engine, and so you can pan and tilt and zoom around the experiment itself. So in this case, I'm really interested in the position of that load disk. So I'm just going to go ahead and start my experiment. And what this is doing is, at this point, the students have been guided to come to this part of the lab. This is them trying based on a simple model, and you can see I've toggled here the model. So what's happening in the background is that it is running a full simulation of the theoretical model, a simple second order model of our cube servo, and right now it's applying a PD controller to it. Hopefully you can see the ringing on the plot. I'm not sure how good the ringing is coming out through the video stream that you have right now, but trust me, once you download the application, you see the full fidelity of the experience on Windows, which is something we definitely want you to experience as well. So right now, I'm just going to keep increasing my derivative gain to dampen out that ringing and those oscillations and get it to a point where it behaves quite well. And you can say this behaves well on my model device. Then the next step of this lab or this experience that we are providing is we ask the students to now try it on the actual, quote unquote actual. And this has more nuanced dynamics. And so this, like Peter mentioned, we know our systems very well. We have them completely modeled to a fairly deep degree. And so part of this now says, okay, these are the nuances between a model and the actual system. And then how do you develop your control system to be robust and be able to handle these unknowns or uncertainties that once you base a control system over a model device, how do you bring it over and try it out on the actual, and what are the differences and how can you account for those when you're approaching any closed loop control problem. And with our buttons, you can try different views, and again, the student is free to go around and take a look at the system itself. This is a simple system, but as we get more complex with things like the arm, the pendulum, and the arrows system that I'm going to show you right now, then there's more rationale to go around and see it. So for example, here we will show you on the arrow. a basic balance controller. And so this is a more complex dynamic system. It's a MIMO system, and it's quite coupled in its dynamics of both the pitch and its yaw. And so the experiment, the user is given or walks through the modeling of the system and then compares it on the actual plant itself and looks for different ways of standard traditional control versus more modern state-based approaches, and really looking at what are the benefits of one versus the other and how you can leverage more information over your system to get it to behave. This is again a simple example, and then it gets more progressively more complex. But for example, it's not reaching where I want it to go, so I can just increase my integral gain, and that'll account for that discrepancy. So this is just one of those examples that we saw, and our goal right now is by the time over the next couple of weeks when we have the complete solution, you will have about 12 different lab exercises around the different platforms that we will be providing, each of them ranging in the 1 to 2 hours per lab experience for the student. And obviously they can continue coming back to it to really solidify their understanding while going back and trying, interacting with the content and these experiments themselves. All right, so I'm just going to exit over here and hand back to Peter.
Perfect. Thanks very much, Paul. I've also now been monitoring a few of the questions, and one thing I'll touch on as I get into the last set of slides here is that as Paul said, this is the starting point. As I've been talking about, this is our first offering, and we'll be building a lot on this as time goes on, not just in terms of the number of labs that we're able to address, but also in terms of the complexity of how we can deliver these experiences. As I said, we wanted to really deliver something today that can be used really effectively in an undergraduate lab context, in terms of students come in, they sit down in front of their virtual hardware, they have an experience where they're able to interact with the system, make observations, answer questions, and get that level of understanding of how hardware and control systems works, and then write a lab report and be able to have completed that activity. But in the future, we have lots of ideas of how we can use these technological foundations to be able to bring much more open and interactive experiences, whether it be through MATLAB Simulink or Python, or much more robust platforms like even our unmanned vehicles, to be able to give researchers and other project-based contexts the ability to have the same experiences. But for now, we wanted to deliver something as quickly as we could to be able to have those immediate requirements for undergraduate activities addressed. And also, the one thing I also realized I had yet to mention was that this is available as a free trial for the next 3 months until Canada Day on July 1st. And so you can download this now from our website and from our online platform, from the online mobile stores, completely free right now and for the next 3 months until July 1st. And on July 1st, it'll be transitioning to a very cost-effective subscription model where you can continue to use it indefinitely for a very low subscription cost, both to institutions and also directly to students, depending on how you'd prefer to deliver that experience. And we really hope, as I said, ending with this particular slide, that one of our legacies as a company we believe and we're really passionate about is when we work with partners and work with academics, they view us as colleagues, not necessarily directly as vendors, and the feeling is mutual. Like we don't necessarily even typically like to call the academics that we work with customers, because really we're trying to find solutions. We're trying to emphasize how can we build something that will make sure everyone is successful, as I mentioned at the beginning. And that's a legacy we're hoping to continue with this platform and with the platforms we deliver on this technology foundation for the next few months and years, is to work with you. And please, again, reach out to us through our email address at info@quanser.com, or also through the website Interactive Labs, where you can download the instructor material. We'll be contacting you after the webinar. We'd love to hear from you to find out how you are using the platform, how you'd like to use the platform, what hardware you'd like us to add to it, and whether you see other opportunities for us to leverage this platform to be able to deliver to you solutions that are really effective and really work for what you do in your teaching and research activities. And with that, I think we'll transition to a little bit more of a question and answer. We'd love to hear from you in the next few minutes.
All right. So thank you so much, Peter, for the wonderful presentation, and I hope again all of you took what you wanted from this, and hopefully if you leave this webinar, we really want you to go on our go to our website, download the Windows application, look for updates frequently there. We will be dropping updates on the Windows side regularly, and you'll be prompted from the app to keep coming back. Soon there will be a mechanism where that app will be able to at the very least, bring you back to our website, if not auto update itself. The mobile side, all of the content will be updated regularly, will be pushed out as well. So you can, once you download it, then that content and those modules will be pushed out. If there are any app updates, it'll follow the similar update scheme of any mobile app as well. So just, there are a lot of questions, so hopefully we can get to a good chunk of them, and I will try to summarize them the best I can. The first set of questions that's come up is around remote labs. Is this a remote lab, or can this be extended to remote labs? So the short answer to that right now is what you've seen today at our start, and the Quanser Interactive Labs that we are launching are completely virtual. They're completely digital representations of our hardware. So is no physical hardware at the back end that's supporting this. And the reason for that, again, was right on the offset. We wanted to make this something seamless and you can get started with tomorrow without having to go in and involve your IT infrastructure at the school, without having to be at the actual lab itself and connecting your devices remotely and making them available that way, because a lot of you, and I'm sure this is going to be true for the next little while, cannot actually get into the school. So let alone get those IT resources. Physically, you can't get into the school. So what we've shown here is definitely that exact paradigm of how you want to access this as quickly as possible and as seamless as possible. Having said that, all our products have always been open architecture, in the sense that any Quanser piece of hardware has access and is accessible remotely. And there are many mechanisms that you can use, and then we've had those webinars in the past. So please look at our previous webinars to test that out as well, to see how that can come together. But we want to work with you, and if that is definitely a need that you want to further explore with us, please get in contact with us and we'll evaluate that capability.
I'll also mention that our experience controls textbook that I mentioned has remote hardware experiences as well, just to give students that hardware experience that we think is valuable and brings a context to everything in control systems, as well as other topics like mechatronics and robotics. And so if you would check out, or ask your students to check out, our experience controls textbook, there are a couple of modules there actually based around this same hardware, the Cube Servo and the Aero, where students can, just for a couple of minutes to get that understanding, connect remotely to actual live hardware at our office and interact with it to see how those hardware effects are manifest.
All right. So another question I will send to you, Peter. So about, maybe you want to talk about both language accessibility and different devices like Chromebooks, for example.
Absolutely. So first off, in terms of language accessibility, we would love to work with you on language accessibility. Unfortunately, we do have a lot of staff who are able to obviously speak different language, being in Canada, but at the same time, that sort of rigorous translation activity is something that we don't typically take on as a company because of the requirements there. But first off, one thing I'll mention is we have in the past translated a lot of our existing curriculum material to other languages where there might be quite a lot of overlap, and we'd be happy to share that with you. Susanna, who's on the call, manages our archive as translated materials. So if you reach out to us, as I said, through the email address that I mentioned, or through the response that you'll get to this webinar, we can look through our archives and find out if we've translated our existing control systems curriculum to your particular language. Also, the mobile platform Experience Controls, we do have a translated version of that into Spanish currently that one of our partners was kind enough to do for us. But because of the activities surrounding this Quanser Labs release, we haven't actually been able to build out that Spanish translation yet. We do have the infrastructure built into our mobile content platform to release multiple translations, but at the moment, we haven't got around to actually pulling that content into the platform yet. But that will be forthcoming in the next few months, or the next few weeks, hopefully. And then also obviously the Word documents released as part of Quanser Interactive Labs. We'd love to be able to translate those as well if in the future. So it's a work in progress in terms of the localization, but it's something that we are working on. And on the other aspect of the question involving how we can
Different platforms.
right, different platforms. So at the moment, the experience right now on Chromebook is there because Google has released on a number of Chromebooks the ability to run Android applications. And so because Quanser Interactive Labs is an Android app as well as iOS and Windows and hopefully soon macOS, you can download, depending on your particular Chromebook, the Android application onto it directly and run it. And we've done it at our lab, even with hardware that was several years old. And so it is possible depending on your Chromebook. And there are a number of websites that you can look at to see if yours is compatible with the Google Play Store, but that should be functional. And also, as I said, the Google Docs are also available, but unfortunately the desktop version that runs on Windows and macOS is compiled specifically for those platforms, so that experience wouldn't be available.
All right, thanks, Peters. We are getting quite a few questions about research. Obviously, a lot of you have worked with us for your research needs, and that's definitely a big part of what we do. You know, we have our autonomous vehicles research studio featuring unmanned systems and drones, flight systems. We just released our self-driving car research studio based around our Q car and leveraging a lot of AI machine learning technologies within that on an NVIDIA processor. So we are very research focused. So right now, the Quanser Interactive Labs that we just launched today will be focused on the undergraduate courses, really trying to reply to the overwhelming demand of how do you take some of these online undergraduate courses and bring them online as seamlessly as possible. So that's what Quanser Interactive Labs is. Like I said, we are leveraging this technology moving forward to really open up the spectrum of what's possible. So we do have a roadmap in place that you will see over the next little while of how we can open up all of our research platforms to be able to have that open architecture and openly accessible access to be able to do things like unmanned systems research, remotely and on virtual and digital products or frameworks in place. So that is part of the plan, and we know that it's challenging to continue your research just as much as continue courses. So we started off with how do you take the courses online as quickly as possible. We will be pivoting and looking at how do we do something similar to all our products, especially on the research end as well. So please stay tuned on that aspect. Let me see another question, set of questions that's come up, and I'll send this to Peter. So Peter, can you tell us a bit more, what will be possible in the future for more open software, things like C, Python, MATLAB, Simulink, and so on?
Yeah, absolutely. So our hardware platforms traditionally have been very open to being fully compatible with MATLAB Simulink through our Quark platform. And also a lot of our platforms have been available to interface to from LabVIEW. And then on top of that, we've also had abilities in the past to, and increasingly more and more now, especially with things like the drone platform and the self-driving car platform, the ability to interface to C, C++, Python, and other languages to be able to give that open architecture experience that I talked about. And we see this platform as being no different. We have technology that we've prototyped and we know is functional to be able to essentially take what you would typically do with our hardware, especially in MATLAB Simulink, where you'd have your diagram open and run actual algorithms or your research or your controllers designed by students directly on the hardware, but have that essentially just really easily through our hardware API work seamlessly with the virtual hardware. And we that will be something that we're working on just to make sure it's robust, make sure that it's gives the experience out of the box that we want it to have over the next few weeks and months. Again, we know we can do it. It's just a matter of making sure that it's going to work for all of the use cases that you have and to give the experience that you're expecting and that we would like you to have with the platform. And so that's definitely, as Paul said, our next thing that we want to do, and also to give that experience with Python and with C and C++ and the rest of the languages we also support. And so right now it's just a matter of taking what we know we can do and packaging it and giving it the treatment that will make it a robust and really reliable platform to make sure that when you do take it from us and use it and adapt it to your research and teaching needs, it delivers on exactly what you're expecting. And so that's what we'll be working on as soon as we've finished the complement of hardware that we're hoping to have for the teaching space in terms of Quanser Interactive Labs.
Okay, just a few questions coming through about just portability over the different platforms and so on. And so just to be clear, our goal is to have all the same approach, same pedagogy, same type of lab experiences to be the exact same for the students, be it on Android, iOS, Windows, or Macintosh. So any of the 12 that we had put up on the list, our goal in the next very short while is to complete all 12 and provide them the same approach, if you will, on those 4 different operating platforms. Obviously, the graphics and sort of interaction will be slightly different, but the goal is to have pedagogically all be the exact same.
Yeah, absolutely. And that's something that will also be, as with everything else, an iterative process. We're rushing to get the material out to you so that you can start using it with your courses as soon as possible, because we understand, especially in North America, there's an immediate need because courses are wrapping up for the spring semester. And so we're trying to bring this to you as soon as possible so you can get those into your courses before the semester ends. But at the same time, one of the aspects that we're iterating on and trying to make sure is robust is that cross-platform experience of being able to show the same capabilities, show the same effects, and have students get the same outcomes on all the different platforms. And so at the moment, they're 100% available on iOS and Android and Windows. Mac OS will be coming in the next few days, maybe in the next week or two. And then at the same time, we'll be refining the models and refining the simulations and the interactions to make sure that everything is that cross-platform experience, and that will be what we'll be delivering in the future. We really want this to be a fully cross-platform kind of experience, and so we won't be diverging from that in the future in adding products that have a lackluster experience on one platform or another. We want it to be consistent across all the platforms for all the different hardware and teaching applications that we address.
Another sort of theme that I'm finding on the questions, and I'll take this one as well. It's overwhelming. Actually, a lot of you are reaching out saying you have one particular piece of software hardware from Quanser, be it our more our previous rotary family, the SRVO2 based product line, or the Aero and so on that people are using via Simulink and would really like to have that experience come to light. And so, like we were mentioning, right now we wanted to provide something as quickly as possible to get off the ground running. We do have plans of opening it up and providing a virtual representation of our hardware platforms that you can use within the same open software. So be it MATLAB Simulink, be it C or Python, we want to provide you with all of that functionality very, very soon as well. And so this is just the beginning. We have a plan in place to allow you to continue interacting and working with Quanser and working with Quanser products, albeit in this new paradigm of distance and online/virtual as well. And so we truly believe, regardless, how this proliferates after a while, this is going to complement our hardware regardless of if you use it exclusively or not. So this is not without one or the other. We truly believe that it's complementary, and we truly believe, the more interactions students especially, or even researchers have with the experiments and with the products, the better they will be of coming out of the course, coming out of their research projects as well. So we do plan on continuing this. This will be part of our release cycles for everything that we do as well. And so we've had this technology for quite some time, and this is the time we really want to leverage it and bring it to the forefront for you to be able to meet your dire needs right now, and hopefully this becomes part of your workflow as well moving forward.
One thing I'll mention, just as Paul's looking at the next question, is that just to make it clear in terms of the roadmap for this particular product, so it's available on the website. You can see today You can download from the iOS and Android app stores, the mobile versions, and you can download from this website, quanser.com/interactive labs, the Windows version, and we'll be updating this particular link as time goes on, where you can download directly from us. And as you can see, the current version was released last night, and we'll be releasing another version today, hopefully, and then further versions as time goes on. And this is free for the next 3 months. It'll be free until July 1st, which is Canada Day. And then we'll be transitioning on July 1st to a subscription model, where there'll be a very cost-effective subscription system that we'll link to from this website, where you can register, you can access an instructor portal if you're an instructor, and set up all of your students with versions of the application platforms, and you can pay for course sessions on a monthly basis to manage your courses and your students. And also there'll be a direct option for students to purchase the platform directly themselves as well. And that'll be the model moving forward from July 1st.
All right, thank you, Peter. So it looks like the questions have slowed down considerably, which is probably a good thing. Hopefully, we've answered the majority of your questions. I think really, like we've tried to say from all along, this is brand new. This sort of came together in the last little while, and so we do expect questions and just we would love the feedback from all of you who are again struggling to take your courses online, and this is really our first answer to help you do that as quickly and effectively as possible. But look forward to having this type of technology roll out in different in different use cases over the next little while. Please connect with us, and please try out these applications. At the end of the day, we can only do so much. It really depends on you and having you push this out to your students and giving us the feedback of interactions with it. And if you have any comments, we'd love to hear from it. And please check back with us to see how this evolves over the next little while as we sort of focus our activities to make a lot of this content more readily available to the masses and not just the beginning that what we've shown here today. So with that, thank you once again for joining this webinar. I think hopefully we addressed a lot of your questions and concerns, and this is just the beginning, and we hope to continue working with you over the next little while. I hope you're all staying safe, yeah, we'll get through this. But I think at the end of the day, hopefully what we do develop together in this new paradigm will stand the test of time and be integrated into the full offerings in the future as well, and not just a solution for the immediate need, but something that can withstand the education as it evolves moving forward as well. Thanks again for joining us, and we look forward to seeing you and hearing from you again.